Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest and other exams related to physical science. Okay, so this is the first lecture of electronics. Okay, and also guys, I would like to request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start electronics. So let's get started guys. Okay, so this is electronics. We are going to start. Electronics. Electronics. Okay, okay, so electronics. So first we'll study types of material. Okay, types of material. Types of material. Okay, so for this is conduction band and this is also valence band, conduction band. Okay, so this is the metal guys. Okay, so metal conductor. Okay, metal conductor has metal conductors valence band and conduction band overlaps. Okay, so metal valence band is okay, they overlap in case of metal conductor. Okay, if we talk about insulator, so this is like this. Okay, this is CB and this is VB valence band, and there is a gap, that is energy gap. Okay, delta EG band gap, and that is equal to 6 to 7 electron volt. Okay, so this is the insulator. Okay, if you talk about insulator, there is a gap between band gap between valence band and conduction band, and that is equal to delta EG equal to 6 to 7 electron volt. Okay, 6 to 7 electron volt. Well, this is insulator. Okay, now next is semiconductor. Okay, so this is semiconductor guys. Okay, so this is valence band, this is conduction band. Okay, this is the band gap delta EG, and that is equal to small one, that is 1 electron volt. Okay, so only 1 electron. So this is conductor band overlaps. Okay, this is the insulator, the band gap is very high, that is 6 to 7 electron volt delta Eg, and this is and for if we talk about semiconductor, the band gap is low, and that is equal to delta Eg equal to 1 electron volt. Okay, well, so this is the types of material. Okay, now we know that is I is the E VD NEAVD, right? This we know, NEAVD, NEAVD, current through conductor. Okay, N is the number density, V is the drift velocity, right? We have studied already in class 12, right? 11, 12, and BSc, MSc as well. So this is NE, E is the charge of electron, and A is the area of cross sectional area of the conductor, and this is VD is the potential difference, right? Like this one, area cross section, cross section, right? VD is drift velocity, electrons are passing, right, going like this, drift velocity. Okay, and also we know that Vd, drift velocity, is equal to mu E. Okay, E is the electric field. Okay, this is the potential. Okay, Vd. Okay, so mu E. Okay, mu is the where mu is mobility, how mobile the conductor that electrons are. Okay, mobility of electrons. Okay, mobility of free electron, these are free electrons in conductor. Okay, free electrons. Okay, E we know that is charge on the electron. Okay, so that is the mobility. So from here we can see Vd, that is drift velocity, is proportional to electric field. Okay, right. Now if in this case, if a conductor, this is a conductor, right, current is flowing and electrons are passing, right. In this case, electron is moving with drift velocity, right. In this case, if in the conductor, if we increase the temperature, okay, if we increase the temperature, that implies resistivity will also get increased. Okay, resistivity of the conductor will get increased. Okay, okay, so resistivity of conductor will get increased. Okay, so temperature increases in the conductor, right, it means resistivity also will increase. Okay, so that means, that implies we have positive uh, temperature coefficient. Okay, positive temperature coefficient. Okay, positive temperature coefficient. Okay, and because resistivity is increasing, that implies sigma, that is conductivity, decreases. Okay, conductivity decreases. Okay, okay, so this is rho is resistivity, and sigma is conductivity. Okay, so if in any conductor, if we increase the temperature, then its conductivity decreases, guys, because if we increase the temperature of the conductor, okay, then resistivity gets increased, because motion of the electrons will increase, and randomness, conductivity will get decreased. Okay, next is this is the case of conductor. Okay, because I can explain, that implies the collision, electrons collision will increase, right, increase like this, increase and decrease. Okay, increase. Okay, that will increase. Collisions of electron increase means the randomness of electron will get increased, right, and the collision will increase. It means the resistivity, will increase, that implies conductivity will decrease. Okay, next is, if we talk about semiconductor, right, if we talk about this is about conductor, guys. Okay, conductor. If we talk about semiconductor, okay, so if we increase the temperature in semiconductor, okay, if we increase the temperature in semiconductor, okay, that means resistivity, in case of semiconductor, resistivity is going to be decreases. Okay, that means negative temperature coefficient, negative temperature coefficient, negative temperature coefficient. Okay, and this means if we increase the temperature, this implies conductivity will increase. So in semiconductor, it's opposite, guys. Okay, opposite of conductor. If you increase the temperature, resistivity is going to decrease, and that means the conductivity of semiconductor will increase. Okay, well, and conductivity, right? And also this is important formula, guys. We'll solve questions. These formulas are important. Okay, we'll solve questions. Next is this one. Sigma conductivity formula is sigma equal to Ne mu. Mu is the mobility, is the charge of electron, and N is the number density, right? E mu is it's important. Ne mu. Next, this is for conductor. Ne mu. Ne mu. Okay, and if you talk about semiconductor, so this is going to be sigma is going to be equal to this is whole number of charge carriers, right? So this is rho, this is rho or P, PE, this is rho, okay, number density, PE mu n plus this is this is charge, positive charge, whole density, right? And this is the electron density of electron. Okay, so n density of hole, this is n equal to density of electron. This P or rho is density of holes. Okay, so this is this is the case of semiconductor. N E mu n. Okay, this is the case of semiconductor. Semiconductor. Okay, semiconductor. So now this is semiconductor. Okay, now there's a Drude model. The Drude model will I'll discuss this in detail in condensed matter physics, guys. So which the course is condensed matter course is going on. Okay, I'll discuss there in detail. Okay, so Drude's model. Okay, Drude's model. According to Drude's model, the conductivity is Ne square tau upon m. Ne square tau upon m. Okay, where tau is relaxation time. Okay, where tau is relaxation time, where tau is relaxation time. Okay, or we can say value of tau is average time between two consecutive average time between two consecutive collisions. Okay, average time between two consecutive collisions. Okay, average time between two consecutive collisions. Okay, well, this is the tau, average time between two consecutive collisions. Next is Ohm's law, guys. Ohm's law, which we know, right? So this is A, and this is B, this is current I, and this is resistance R. Okay, so we know by Ohm's law, potential difference, right? Potential drop VA minus VB. Okay, right? Okay, right? So this is the Ohm's law, or V equal to IR, length of conductor. Okay, R is proportional to L. L is length of conductor, length of, and R is inversely proportional to 1 upon A. A is cross sectional area. A is A is cross sectional area, right? So from here R is proportional to L upon A, or R is equal to rho L upon A. Very important formula. Okay, you need to know. Rho is the resistivity, R is resistance. Okay, R is resistance. Okay, this one. Okay, R is resistance, and also you need to know this RT. The resistance at temperature T is equal to resistance at, very important. Okay, resistance at T equal to 0 Kelvin. Delta T is the temperature difference. Okay, where alpha is thermal expansion. Okay, thermal expansion coefficient. These are basic things, guys. Basic things of electronics. Okay. Series combination. Okay. So this is the, we'll make a series combination. Okay. So this is R1, R2, R3. Okay. So this is V1, this is V2, and V3. Okay. And in series combination, we know that is a drop is different. Okay. So for this we'll make a equivalent circuit. Okay, so equivalent circuit is going to be like this. Okay, so this is R equivalent, okay, and this is R equivalent. Okay, and this is this one R equivalent. Okay, this is electromotive force. Okay, so here we can see, since electromotive, this sigma, this epsilon is going to be equal to electromotive force E is going to be equal to this one, V1 plus V2, V1 plus V2 plus V3. Right? This is V1 plus V2 plus V3. We can write this is going to be from here epsilon is going, E is going to be I R equivalent, right? So I R equivalent is going to be V1 V2 means I R1 plus I R2 plus I R3. Right? Current is same in series combination, right? So I will get cancelled. So from here R equivalent is going to be R equivalent is going to be R1 plus R2 plus R3, right? Important result for series combination. Next, parallel combination. Parallel combination. Parallel combination. Okay, parallel combination like this. Voltage drop is same. Okay, so this is going to be, and so current is different. Okay, current is different. In series, current is same, voltage is different. Okay, these are main points. Okay, we need to know. in parallel combination. Okay, so from here I equal to I1 plus I2 plus I3, right? We'll make a equivalent circuit here. So equivalent circuit is going to be like this. This is E, this is R equivalent. Okay, R equivalent. This is the equivalent circuit. So I1 equal to I. So I means the V voltage drop is same, right? So E upon R equivalent, I value E upon R equivalent upon E upon R1 plus E upon R2 plus E upon R3, right? E will get cancelled. So this value is for parallel combination. This R equivalent is going to be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, this is important result. So this is the R equivalent for parallel combination. Okay, well, now current divider rule, guys. Okay, next is current divider law. Current divider, very important law, guys. When we solve circuit related questions, so we will use this divider law. Okay, current divider law. Okay, so I'm going to explain it. So this is like this. Okay, this is A, current is I. Okay, and this is R1, this is R2. Okay, and this is I1 and this is I2. Okay, and we need to, and we'll make a equivalent circuit for it. So this is going to be A, B and R equivalent. Okay, A, B and R equivalent, and this is I. Okay, so now we know in parallel combination, parallel combination, parallel combination, parallel combination, current always, current always gets divided in the inverse, gets divided in the inverse of their resistance. Okay, inverse of their resistance. Okay, so in parallel combination, current always gets divided in the inverse of their resistance. Okay, and we know R equivalent is, this is R1 R2 upon R1 plus R2, right? This we know because 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2. If we solve it, we'll get this value. Okay, so this one. So R equivalent is R1 R2 upon R1 plus R2, right? This one, R1 plus R2. So from here, and we know this VAB, right? This voltage VAB, the voltage is VAB is equal to, we know that I R equivalent, right? For this case, I R equivalent, right? That is the VAB. So VAB value is this, right? So now we'll find out R1 I1 equal to, I1 is going to be this VAB upon R1, VAB upon R1 for this circuit, right? I is going to be, this is voltage is right, VAB upon R1. VAB upon R1, this is I1, right? We'll put the value. So this is going to be I R1 R2 upon R1 plus R2 into R1, right? R1 will get cancelled, so this is going to be I R2 upon R1 plus R2. Very important formula, right? This is the I1, guys. And similarly, we'll find I2. I2 is going to be VAB upon R2. VAB value we know, R1 R2 R1 into R2 upon this one R1 plus R2 into upon this R2, right? R2 will get cancelled, so this is R1 upon R1 plus R2. Important formula. I'll tell you the trick now, guys. Okay, it will be very easy. So I'm going to tell you trick for voltage divider. Okay, so this is simple. Okay, so this is like this one. Okay, this is R1, this is R2, I2, I1, this is I. Okay, this one. So now we'll use trick. So by trick, I1 is going to be I1 is this R2 upon this one R2. Okay, R2 upon R1 plus R2, right? And similarly, I2 means this R1 upon R1 plus R2, and I is also there, right? I is the total current. Okay, I and I. Very simple. So this we have to find I1, means I into I1 we need to find I into R2, this R2 upon R1 plus R2. And if we have to find I2 means R1, right? I into R1 upon R1 plus R2. So I will multiply I. If we have to find I2 means the other so what we'll do is we'll just multiply R1, that other resistance, into I upon R1 plus R2. So by trick you can easily find out, right? So I1 means R2 upon R1 plus R2, and I2 means I R1 upon R1 plus R2. Okay, so this is the voltage divider rule, very important. Okay, I'll give one example for voltage divider rule. Okay, example, suppose this one. We have I, that is 10 ampere. Okay, R1 is 5 ohm, this is R1. Okay, and R2 is 15 ohm. Okay, now this is I2 and this is I1. Okay, this is 5 ohm, this is 15 ohm, this is I2, and this is I1, this is I2. Okay, so from here we can find I1 means I into R2. I1 means I into R2 upon R1 plus R2, right? So I means 10 into R2 is 5 upon 5 plus 15, right? If we solve it, this value is going to be 7.5 ampere. Similarly, we'll find I2. I2 is going to be I into R1 upon R1 plus R2. Okay, so this we can say I means 10 into R1 is 15. This is I1, R2 here it's 15, guys. Okay, it's 15, so 7. And then now I into 5, this is 5, R1, right? I2 5 upon 5 plus 15, and this value is going to be 2.5, and you can see ampere. Total current which will pass will be same, that is 10 ampere. Okay, 7.5 plus 2.5 is 10 ampere, right guys? This is the current divider rule, guys. Current divider rule. Okay, current divider rule. Okay, well guys, so I'm going to stop here, and also guys, I would request you who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, okay guys, thank you so much. Bye now.